Okay, so today's class will discuss local search algorithms or heuristic. So far, what we have done, we have completed the introduction section, which talks about what is AI. Okay, and then we discussed how a problem can be represented as a state space problem. Then we discussed the basic search techniques known as uninformed search, which is searching the state space when no information is available. Okay, and especially we have discussed breadth first search and depth first search. Okay, and we found out that among these two, BFS is better because it is optimal and it eventually gets to the solution or the goal. Okay. So now onwards, next 4 classes, we are going to again discuss the search methods, but this time the informed search. So these are all informed search. Okay. So in this next 3 classes of next week, we'll solve problems and see the basic informed searches. Today's topic is what exactly enables the informed search. Okay, and that is known as heuristics. So that is known as heuristics. So in mathematical programming, we have a fixed formula, we have a fixed logic, or we have a fixed iterative formula, just like Newton-Raphson method. Okay, you have a formula that you have to follow. But in general problems or the problems on which AI works, we do not have a fixed formula. Rather, we create our solution based on the nature of the problem, just like in life. Okay, so we cannot just have one single solution approach for all the problems, okay, and then apply to that. No, it's not possible. Every time we face a problem, we have to find a solution. Okay, every aspects of life, there might be something which is constant, but then, for example, today's class, so I saw that one class was missed. According to my plan, we need to complete this by this week, this class. So I told you that okay, today we'll have an extra class. Okay, so that is known as heuristic. So everything on the go, whatever method you develop. Okay, one heuristic may not be applicable for other domains. Okay, it is only specific to the particular problem. Okay, but when you have a set of heuristics, at least you can apply them to some set of problems. Okay, and about local search and global search. Global search means finding the final optimum, but then sometimes local search is important. Okay, just like you would say that what is the best career goal for you? Now you have something in your mind. But if you only try to reach the global solution always, then you may face problems. So initially, you have to get settled as the local optimum, maybe a campus job. Okay, then you will try for the global one. Okay, so there are some methods which are known as local search methods. Okay, so now we will move to the presentation. Okay, so today's topic is local search and heuristics. 1st August, lesson 6, class number 6, I think. Yes, lesson 6, class number 6, 1st August. Okay. So what is the difference between local search and global search strategies? So you have discussed typical optimization problem which says minimize certain objective function subject to constraints. In fact, this can be minimize or maximize. Minimize cost or maximize profit. For example, maximize your class attendance subject to all the constraints you are facing. Maybe hostel issues, personal issues, sleep issues, whatever. So those are all the constraints. So you have to maximize that attending the classes. But then there is no fixed formula for this, is it? Okay. So in many optimization problem, the state space is the space of all possible complete solutions. The objective function tells us how good a given state is. It gives a number to a particular solution. Okay. The solution is obtained by minimizing or maximizing the function. This you have completed in your third sem. Soft computing and optimization. Local search algorithms do not systematically explore all the search space. Okay. Rather than we use a heuristic function. So we are not bothered about the final goal or which is the maximum goal. Okay. Rather we are concerned about what is immediately best for us. Okay. Algorithms do not usually keep track of the path traveled, thus the memory cost is minimal, though total lack of memory is an issue. Memory cost is minimal in case of local search, isn't it? Suppose you think too much about your future 10 years down the line, so you get confused, right? So, but if you focus on immediate goals like I will prepare for GATE, I will appear for campus interview, then the concept is clear, right? You need not remember too much of your plan. Okay, that's why it is not that much memory intensive. But then, if you are too local, then there is also an issue. Like total lack of memory is a problem. So in that case, you will be lost only in local solutions. Okay. The local search algorithms use single current state and move to a neighboring state. Okay, useful for pure optimization problems. Okay, so one of such local search methods is hill climbing search. Okay, hill climbing is a heuristic local search algorithm that iteratively moves towards a better optimal solution. Operating like a hiker scaling a peak in a dense fog. Okay, some hiker scaling a peak and a fog is there, so he won't say that I will go to the peak. No, he is just trying to get to the next one which is available. That may not be the global one. Okay. Operating like a hiker scaling a peak, the dense fog, it evaluates the immediate surroundings and takes the continuous steps. Okay. And then improvement until summit. Then slowly it improves. Hill climbing algorithm is a greedy approach. What is a greedy approach? Greedy approach means get whatever is available or just keep it whatever is available. Okay, don't focus on too high idealistic goal. Okay, it moves in the direction that optimization of objective function. The strategy aims to find the optimal solution efficiently by making the best immediate choice. Best immediate choice without considering the overall context. So hill climbing is an approach, an algorithm to solve a solution where we apply only among the local solutions rather than bothering about the whole context. So what are the steps? Initial states, start with an arbitrary solution, random solution, identify the neighboring states, then move to the neighbor, and finally repeat the process till you reach your summit. Okay, it's an iterative process. This is an algorithm for or approach how hill climbing looks like. See, this is the global optimum. This is where a person should actually reach. Okay, suppose you are standing here, somewhere here. Okay. Now you see that this is the nearest best solution. So then you may go here for local purpose, initial purpose. Then you can move to the global one. But there are certain situations like flat maximum, where it is the algorithm is unable to know whether actually it has reached the optimum or not. Here it is known because if you go move to next, then it is cost is lower. Okay. So objective function state space. This is the maximization problem. So this is a global maximum. Okay. But we may be stuck in the local maximum in hill climbing. So one of the heuristics can be estimate of the distance from the peak. One of the heuristic. Next peak. Okay. So what are the various types of hill climbing search? So first one is simple hill climbing algorithm. Evaluates each neighboring node one by one and select the first node that offers an improvement over the current one. Okay, simple hill climbing. Okay, steepest ascent means slope. We see the slope. Instead of moving to the first neighboring node that improves the states, it evaluates all the neighbors and moves to the one which provides the highest improvement. Okay, stochastic hill climbing. It uses some stochastic means probabilistic approach or method. Randomness. So it introduces randomness. Randomness means we to model randomness, but approximately we model randomness by various probability distributions. Okay, say wind speed follows Weibull distribution, or something follows normal distribution, electrical load. So in such case, we use some stochastic or probabilistic approach to find out the next. Instead of evaluating all neighbors or selecting the first improvement, so we select a random neighbor based on some stochastic algorithm. Plateau is a flat region where neighboring states have the same objective function. Just I have shown you plateau. Okay. Ridge, a higher region with a slope which can look like a peak. Okay, this may be a peak or something like this. This may be a peak, but actually it is not a peak, it's a ridge. Shoulder, it's a plateau with an uphill edge allowing the algorithm to move towards a better solution if we search continuously. This is the nature of the hill climbing algorithm. The next one is similar approach is simulated annealing. And what is annealing? Annealing means heating and cooling the metals so as to preserve some physical properties. Okay, a hill climbing algorithm never makes a downhill move. Okay, so sometimes we have to make a downhill move. Okay. Under such certain situations, you have to cool down, right? You have to make a downhill move. It's like suppose a fighting ensues on the road. Okay, so it is always better to cool down, leave the place, and go. Okay, rather than some cathartic reactions, sometimes it is better to get away from a fight rather than taking it to the end. Okay, so sometimes you have to move downhill. Okay, non-optimal solution. You have to go for temporarily so that eventually you will get to a better solution. Okay. So that's, but hill climbing does not go for that. If you apply hill climbing to a local fight or a street fight, then the approach is always fight till the end. Okay, but that is not the right approach. So in such a case, simulated annealing is, it allows downhill moves whenever required. So purely random walk moves to a successor chosen at random. So another algorithm is known as random walk. Okay, it is very simple. Randomly next step, and just then evaluates whether it is the best one or not. Okay, when you don't have any information. Simulated annealing combines hill climbing with random walk. Under such certain situations, like a street fight, if you apply simulated annealing, then the next random step, as you feel, is okay. Let's leave it go. We'll think about it later. Okay, because it is causing problems. Idea: to take occasionally steps in different direction from the one which increases or decrease of energy is maximum. Okay, so randomly you go in certain directions, simulated annealing, rather than a strict hill descent. Okay, hill climbing. Thus, simulated annealing is a stochastic hill climbing. What is stochastic? Stochastic mane kona? Stochastic mane hochi which direction I should go. Okay, I will use probabilistic approach. So I have suppose say that my problem follows gamma distribution. So I will put the parameter to the gamma distribution and I will make a condition. If it is greater than 0.6, I'll move in this direction. Less than 0.6, I'll move in the other direction. Okay, so that is known as stochastic algorithm. Okay, that means it allows a downhill move. Suppose the probability is less than 0.6, then I will take a downhill move. Okay, right? So a successor is selected among all possible using probability distribution. Okay, as I told you, probability distribution. The successor can be worse than the current state. Yes, sometimes we feel like we are moving, actually taking a downturn, but sometimes it is desirable. Okay, sometimes we have to stand back, okay, so as to win later, just like in those retreat in the wars. Okay, so sometimes you have to retreat, okay, so as to eventually win. Simple random steps are taken in the state space. So simulated annealing is inspired by the physical process of controlled cooling. So a metal is heated up to a high temperature, then progressively cooled in a controlled way. Okay, if cooling is adequate, the minimum energy structure is obtained. So as you know, the minimum energy structure is the most stable one. Okay, so sometimes taking a downhill move helps us move into a more stable solution, okay, which is desirable. Okay, next. So goal of annealing is to, this is the description of the simulated annealing. See, nobody will ask you in the exam about applying this algorithm to solve a problem. Mostly the theoretical aspects, okay, that will be asked. Okay, describe the simulated annealing and hill climbing algorithms. So you have to write the nature of the algorithms. The goal of annealing is to produce a minimal energy final state, but there is some probability that a transition to higher energy states will occur with a probability of this. Okay, that means it's a downhill move. It's a downhill move. In simulated annealing, delta is generalized to reflect the change in value of the objective function. With when temperature tends to 0, it is simple hill climbing. That means under a low stress environment, when you say temperature is tending to 0, the corresponding real life situation is low stress environment, 0 stress environment. So in that case, you apply hill climbing. Okay, but when temperature is high, that means when the stress is high, when you are in a situation when you are very angry. So in such case, it is always better to go downhill. Sometimes it is better to go downhill rather than always trying to find the optimal solution, always fighting. That's what it says. So as the function f decides the selection of the successor state and depends on the T, okay, temperature. The lower the temperature, the lower is the probability of selecting or successors, right? The lower the stress, you can make idealistic better decisions. Okay, but when the temperature is high, sometimes it is always desirable to go for a coarse solution. Okay, but when the temperature is lower, we generally don't go for it. Suppose you have enough money and time, then in that case you sit down, prepare, and get to your final job in the first attempt itself. But that is not always possible, right? Annealing means when the amplitude of the random state is sufficiently small not to allow to descend the hill under consideration, the result of the algorithm is said to be annealed. That means when we are nearing the final solution, in that case we are in a stable solution, we need not further apply this random works. Okay, then it becomes hill climbing, simple hill climbing. Okay. What is the meaning of heuristics? Okay, so two local search algorithms we have seen. One is hill climbing and the other one is stochastic hill climbing, or also known as simulated annealing. So the next one is, what is the meaning of heuristics? I told you heuristic means some some formula, okay, or some approach that is specialized for only a particular situation, may not be applicable to all situations. Okay, the study of methods and rules of discovery and invention use our knowledge of the problem to consider some successor of the current state. This means pruning the search space, even missing a solution. So we use heuristics, okay, so as to find the solution fast, but that may not be the optimal solution. Okay, so write down this heuristic function. A heuristic function takes a state and returns a numeric value. Which is a composite assessment of the state. Okay, in AI, heuristic function estimates how close a state to a goal. The function takes a state and returns an estimate of its distance or path cost from the goal state. Okay. Now, what is an admissible heuristic? Is the one if it never overestimates the cost of reaching a goal. Okay. So heuristic should not overestimate. It might underestimate. Okay, but it should not overestimate. Thus, the only thing required for a heuristics to be admissible is that it never returns a value greater than the actual path crossed. Okay, so that is not allowed. Okay, it might allow an underestimate. Okay, now we will see various heuristic measures. So the first heuristic measure is known as Euclidean distance. The least distance, it is the straight line distance between 2 points. For example, from myself to the last one, it will be a simple straight line distance. It may not be possible to go in this direction, but that is the lowest distance. So that is known as Euclidean distance. Okay. So derived from Pythagorean theorem, it measures the shortest path connecting them, and you know this mathematically it is done by square root of the square of the distance between them, Euclidean distance. Related to this, you might get problems in the exam. Okay. So for n dimensional case, this is the solution. Okay. Now the other one is Manhattan distance. So what is the Manhattan distance? City block distance. For example, I want to move to that person, then I will go straight in this direction and again in that direction. So that will be known as Manhattan distance. Okay, street block, like street blocks. So known as city block or taxi cab distance measures the total absolute distance between the 2 points on a grid. It calculates the sum of the absolute differences of their coordinates exactly like taxi navigating. So it is simply the absolute distance in this direction, in that direction. Okay, not the shortest distance. Okay. Did you write the formula for Euclidean distance? Write down this formula for Euclidean distance. For 2 points x1, y1 and x2, y2 in a 2D plane, the formula is distance is equal to x2 minus x1 square plus y2 minus y1 square. Okay, write down this. Okay, whereas Manhattan distance is x1 minus x2 absolute plus y1 minus y2 absolute. Okay, for example, if point A is at 1, 2, B is at 4, 6, the Manhattan distance becomes 7. Whereas if you take Euclidean distance, what will be the Euclidean distance? It will be 1 minus 4 square plus 2 minus 6 square root over. What is that? I think 9 plus 16. 5, right? Whereas for these 2 points, the Euclidean distance is 5, the Manhattan distance is 7. So is it clear? Manhattan distance and Euclidean distance, we will be using this in our next 3 classes. Clear? Euclidean distance simply square of the root of square of the distances, sum of square of the distances, whereas Manhattan distance is absolute value of distances. Okay. Now, just look at this and draw it, these distances. Okay. So as you see here, Euclidean means direct distance. Okay, this one. That means this distance is 1 square plus 1 square. Right, this is 1 square plus 1 square root of 2. This distance, this is root of 2. Whereas this is 1, 1, 1, 1. That is Euclidean distance. So taxi cab means Manhattan distance. So this is Manhattan distance. So if you see here, this is 1, whereas this is 2. That means you go in this direction. Again, this direction 2, this direction 2, this direction 2. Okay. So this is Manhattan distance or taxi cab distance. Then Chebyshev distance is only one block. Right? One block, one block, one block, one block. This is Chebyshev distance. Okay. But we won't be using this, we will be using only these two. Okay. Euclidean and Manhattan or taxi cab distance. Hello? Okay, then next comes Hamming distance. Hamming distance is like, suppose we take 8 puzzle and we have a goal state, we will simply count how many blocks are at the wrong place. Okay, that is Hamming distance. Okay, it's kind of a error code. In computer science and telecommunications, Hamming codes are family of linear error correcting codes. Hamming codes detect 1-bit and 2-bit errors or correct 1-bit errors without detection of uncorrected errors. Hamming distribution to integers is the number of positions at which the corresponding bits are different. Okay, that means one change. In 8 puzzle, okay, how many, another example of Hamming distance, anyone who can give? 8 puzzle ketra, what is that called? Those blocks are in wrong place. So it is known as Hamming distance. At the goal stage, what is the Hamming distance? Goal state, final goal state Hamming distance कौन होगा? 0, because none of the blocks are in wrong state. Okay, so that is Hamming distance. It is not dependent on the actual values only if they are equal or not. For example, in 8 puzzle, okay, you need to write it down. The other distance that we are going to use, apart from Euclidean and Manhattan distance, especially for the 8 puzzle problem, is the Hamming distance. So in 8 puzzle problem, the precise number of misplaced tiles is the Hamming distance. So that is precise number of misplaced tiles. Okay, so misplaced, write it down. This is Hamming distance. In 8 puzzle game, write it down. In 8 puzzle game or problem, the precise number of misplaced tiles is a Hamming distance. Right? Okay, I took it from the NPTEL course. Now suppose this is the typical 8 puzzle game, and say this, there are several goal states. Suppose this is the goal state 1, 2, 3, 4, 5, 6, 7, 8. This is the goal state. Okay. Now compute the Hamming distances in all the 4 cases. इतने Hamming distance कितना होगा? H1n क्या है? अब ये तीनटा जाकर Hamming distance कितना हो? Compute the Hamming distance. देखिए, so we'll see. Okay, the answer to they need. Okay, so you find out. Okay, here Hamming distance, Manhattan distance. Okay, you solve this. State. This is the goal state. This is the start state. So what is the Hamming distance? What is the Manhattan distance? Compute. Correct. Solve it. Manhattan. Okay. So Hamming distance is, we'll see each tile and see whether it is misplaced or not. That means 1 is misplaced, 2 is misplaced, 3 misplaced, 4 misplaced, all 8. So Hamming distance should be 8. Manhattan distance means from 7, how many blocks I have? This correct one. 1, 2 plus 1, right? 2 plus 1, 3. So we'll start with 1. Okay. 1 should come here. That means in this direction. That means 1, 2, 3. Right? So for 1 it is 3. For 2, 1. For 2 it is 1. Right? For 3, 1 plus 1, 2. Okay, like that you have to compute. So that will be the Manhattan distance. Okay. Compute. Let's see. Compute. Yes. Okay, now we will calculate. Yes. First chance you have made it correct. Okay. So Hamming distance is 8. Manhattan distance is 18. So for Manhattan distance, you have to take the minimum distance, right? Okay. Then I have given several such blocks, and I have computed Hamming and not I have they in that course they have computed the Hamming and Manhattan distance. So you cross check it, practice it. Okay, if you practice for all these blocks, then you will be thorough about the Manhattan and Hamming distance, because next 3 classes will be using this as if you are thorough with it. Okay, so today itself within these 2 days practice this. Okay, this slide especially, that's why I have given it. For each of these cases, compute Hamming and Manhattan. This is another such problem where you can use Hamming and Manhattan distances. This is known as 8 block solved problem. That means target hoji will start with A, E, B, C, D, F. This is the target goal. But now they are like this. So with how many steps you can reach there? So you can find out Hamming distance, that means number of misplaced blocks. How many blocks are misplaced? A is misplaced, it should have been at the 4th. So like that you have to compute. Okay. Okay. H2 is, I think, Manhattan distance. They have written. So here the heuristic is add 1 for every block that is on the correct block and subtract 1 which is on the wrong block. So these are not Hamming and Manhattan, I was wrong. So these are 2 different heuristics. So compute these 2 heuristics for these 2 problems. Okay. Next concept is problem relaxation. Okay. Problem relaxation means you relax the rules for some time. Okay, rather than saying that you can only make the moves on the right direction, rather than saying that, you can say that okay, you can make the moves in any direction. Okay, so that is known as problem relaxation. That takes some more time, but it is beneficial in certain situations. A problem with a fewer restrictions on the actions is known as problem relaxation. The cost of applying solution for the relaxed problem is an admissible heuristics. Okay, so we said that heuristics should not overestimate. Right? It should not overestimate. It can underestimate. But then for a relaxed problem, it is allowed. The heuristic that we say get for a relaxed problem is allowed. Okay, consider the 8 puzzle problem with the following heuristics: number of misplaced tile, total Manhattan distance. Okay, if the rules of the 8 puzzle relax so that tile can move anywhere, then H1n gives the sorted solution. For example, you asked which direction I should take for the tile. Should I take on the right side or left side? I told you take the minimum one. But in certain situations, you will be said that okay, you can move the tile only in clockwise direction. So that is a condition. So in that case, accordingly, you have to compute. The rules of the 8 puzzle relaxed that a tile can move to any adjacent square. Okay. Why it told? Because 8 puzzle le got a blank space thai. Okay, there is a blank space. You have to go through that blank space only. Okay. The next concept is composite and consistent heuristics. It's a theoretical thing. You read about it. Okay. So with this, the heuristic is complete. Heuristic, mane today's class was about the tool that we are going to use for the next 3 classes. Okay. So for this classes, for the block solve problem as well as the 8 puzzle problem, be thorough with the computation of the heuristic measures. Extra thing I think I have given in the extra resources, check that.